Hello guys, welcome to my YouTube channel. Our today's topic is basic method. We will compute fiber stresses in a pre-stress beam by the basic method. So here is an example. We will solve this example. Okay. In this example, you clearly uh, read that this is a T-beam. Okay. Here, if I go to figure, so you can see that it's a T-beam. Details are given. So in this example, we will compute the extreme fiber stresses at mid-span. There is two conditions. First, we will apply initial full stress with no external gravity loads. And the second condition, we will compute the extreme fiber stresses at missed span with the condition final service load conditions when pre-stress losses have taken place. Okay, in the given data we are given with the WST, dead load intensity, live load intensity, and initial pre-stress losses. We are given with initial pre-stress losses, and also we are given with allowable stress data. Here is you can read it, and also we are given with the sectional properties like AC, IC, R square. The we are given with these properties, and we will also use these properties: eccentricity at center, eccentricity at support, section modulus. Okay, self weight is also given. So let's move to the solution. Here in the solution, we just write first given data WST plus WL, and there is initial pre-stress before losses, and this in initial pre-stress losses, you can see that FPI is a representation for initial pre-stress loss. This is equal to 0.70 FPU. Okay, this FPU is basically the specified tensile strength of tendons. We are given with this specified tensile strength. Okay, so when you put this FPU here, you will calculate FPI. And effective pre-stress losses, we are given with effective pre-stress losses, effective pre-stress after losses, FPE. Okay, so you have calculated FPI and FPE. Initial condition is in the first condition the initial full pre-stress and no extreme gravity load. So in this case we will use PI. Okay, we will use PI. As you know, we are in the initial full pre-stress. So the load will be initial load PI. PI is equal to ASP FPI. So here we calculated the initial pre-stress, initial load. ASP is basically ASP. How we calculate ASP? We are given with the 10 half-inch 7 wire straight. So this is a fix. This is a specified value. This is a specified value for the 7 wire straight having half-inch dia. So this is from the tables, or this is a fixed value. Okay, in this way we calculate ASP, and after ASP, sorry for that, it's just moving so quickly. Let me adjust its sensitivity. Okay, now it's okay. uh, so in this way we calculate PI, and in this first condition, when the initial full stresses are used with no external gravity load, we don't need PE, but we just calculated it for the second condition when service loads are applied. So just ignore this for just ignore this PE. We calculated PE same like we calculated PI. Okay. Next step is movement at mid-span due to self-weight. We calculated movement. We calculated movement MD due to self-weight. Remember this. We are given in the initial condition that no external gravity loads are applied, so we will not go to the moment. We will not find a moment due to external gravity loads. We will just find the moment at mid-span due to self-weight. So here we calculated this moment. As we know from the basic method, we know the formulas to compute extreme fiber stresses. For top FT, this is the whole formula. So just you have to put pi. You have to use pi here as we are in initial pre-stress case. And MD, you have already calculated MD. Put MD here. Remember, there we have to put EC eccentricity at midspan. We have to put eccentricity of midspan as we are calculating computing we are computing at extreme fibers at midspan. Okay. Similarly, when we calculated this FT, so this is the top extreme fiber stresses. This negative sign shows that these are compression stresses as our top is in compression. So let's check for the maximum allowable stresses in the concrete. This is the check. This is the check when we are calculating initial pre-stresses. This is the check when we are calculating initial pre-stresses. Here it is mentioned that it is mentioned that it is mentioned that maximum allowable stresses in the concrete at initial pre-stress. Okay, here it is mentioned that. So when we apply a check, it is in limits, so it's okay. So let's move further. Okay. Okay, here we just apply a check, and after that we will calculate FB. So FB is stresses at bottom fiber. So just the changes will be like SB will change, and SB will change, and similarly SB will change, and CB will change. Okay, these two changes will be here. There will be just two changes, like just highlight me this and this. This is how we calculate. And yes, the formula is also changed little bit. Let's apply a check for the bottom fiber. So here is also it's okay. So let's move to the second condition. In the second condition, the final service load condition, when the pre-stress causes have taken place. So pre-stress causes have been taken. Let's find a moment. So moment at midspan due to superimposed dead loads. Okay, these are the gravity loads, or you can say external gravity loads, which are now considered. So we are in the service load condition. Okay, so let's move further. Just we have to put that loads in the required equations. So we will find, remember there in this case we will use PE instead of PI as we are in service load conditions. And just ask me questions in a comment if you didn't get any point, any concept here. So similarly, when we find ft, we have to apply a check. A check is maximum allowable compressive stresses in concrete at surface. There is a mentioned in the question. Everything is given. These checks are given. Here it is mentioned service word. So you have to apply this check when you are calculating stresses at service conditions. Similarly, let's find bottom fiber stresses. So here also you have to apply checks maximum allowable tensile stresses. As you know, the bottom fiber has to be have to be checked for the tensile stresses in a concrete. So in this case, Ft is equal to 12 Fc prime, and you have to check that. And this is also okay. So here in this numerical, we just apply a basic concept. So if you didn't get anything, any concept, any point in this numerical, just ask me in a comment. I will reply and I will further explain that. Thank you for watching.